At this point, we have looked at 2 examples in words of composition of functions. The point of these examples is to look at the notation. And so for these examples, we have functions given in function format, and we want to look at that full function notation. So the first question that we have is to find f of 3, and this is reviewing that function notation and what this all means. So what we understand is that when we find f of 3, this means we want to replace x with 3 in the f function. So I look at my f of x function. I see where the x is. I replace it with the 3. So this is going to be 5 times 3 plus 7. I do that math on my calculator, and I get 15 plus 7, which is indeed 22. So that is the original function notation. So then when I go to the next one, this one with all of these parentheses, this is function composition in the function notation. So the outer one is the f, and so like the same as the first one, the f, that's the function that I'm going to be substituting something into. Inside the parentheses is g of x, which means that g of x, this function, is what goes in for x. So I start with the f function, so I'm going to write 5. And then where the x is, where last time I put the number 3, this is where I need to put the g of x function. So I'm going to put x plus 2 quantity squared. And then I move on and I finish the f function, so plus 7. Now, the wonderful thing is that WebAssign does not make you simplify, and neither will I. So we're just done at that point. Simplifying here would be a lot of work. We would have to use the FOIL process to expand the square of x plus 2, then distribute the 5, then add 7. So we don't need to simplify. We just had to substitute in one function into the other to have a single formula. So we're going to try it with the opposite way. I am going to change pen colors here so that we can see how it turns out different. And the ordering of this is so important. So here we're asked to find g of 2. That means we're going to put 2 into the g function. So I look at my g function. It starts with a parenthesis. I replace the x with a 2. So 2 plus 2, quantity squared. I can do that math in my head, and that's going to be 4 squared, which would be 16. Now, similar notation, but composition. I'm asked to find g as f of x. So in my parentheses is the f of x. This is going in for x. So this f of x is 5x plus 7. This is going in for x. And so I just have to work at how I write it. So the g function had a parenthesis, and then where the x is, I'm sticking 5x plus 7. Then the g function had a plus 2, and the parenthesis squared. This answer is technically right. The simplifying here is very easy, so I am going to do a step of simplifying. So I get 5x plus 9, and then that quantity squared. And so I did combining of like terms within the parentheses. 7 plus 2 is 9. And then that is my answer. So the g of f of x is equal to this function. And that is composition, substituting one function into another. You can clearly see here that order really matters. So when I had f of g of x up here versus g of f of x down here, these are two very different answers. So this composition, this ordering, where I'm plugging in the g function, gave me this answer. And then the final one, this ordering, where I'm plugging in the f function, gave me this answer. So I do have to pay attention to the notation. The one that is first is like the function that you're using, and then you're substituting what's in parentheses into that function. So we're going to try it with a second example, And specifically, I picked this example because the fractions are really weird, but because we don't have to simplify in WebAssign, that helps us out a lot, and we can just leave them as some really weird fractions rather than spending a lot of time on our fraction rules. So the first one that I have is find f of 7. So that means 7 goes in for x in the f function. So I look at my f function, and I see the x's on the bottom, and I replace that with 7. So my answer, 4/7. So that, very straightforward. Now, my second one is very similar. It's the f function again. So when I look at the f function, the 4 is on the top. I have that on the top. I pick the f function. And that, what I'm plugging into that is g of x. And so the g of x function is replacing the x. So this full g of x function is replacing the x here. So the denominator of this is actually 3 divided by x. And that looks really strange to have a fraction within a fraction, but WebAssign will allow you to type it that way, and for all intents and purposes, it looks ugly, but it is correct, and so we're going to go with it and not worry about all of the simplifying involved there. So next we're going to try a similar thing with the g function being the controlling function. So I'm going to erase a little bit here of my notation. Here we go. And change to a different pen. So first I'm asked to find g of 9. And since it is g, that means I'm going to put the 9 into the g function. So when I look at the g function, 3 is on the top of that fraction. I'm going to replace the x with a 9. This is a good answer. If you would like to, you may simplify that. And so 3/9 is the same as 1/3. But simplifying is not required. Now I'm to find g of f of x. So again, g is on the outside. That is the function I am to start with. So I start with the 3 on the top. F of x is in the parentheses, so that is what I'm replacing the x with. So f of x, this 4/x function, is going in for the x down here. And so the denominator is going to be 4/x. And again, we pick out those nested fractions, which is really odd looking notation-wise, but it is something that WebAssign will accept, and so we're just going to let it like that. And so that is the formal notation for composition. We have to remember composition is substituting one formula into another, and so the thing that is in the parentheses is what is going in for x. And the thing that is outside of the parentheses, the f or the g,